Hello, Fahad.
Hello, sir.
Everything good?
Yes, sir.
Any doubts from the last class?
No.
All right. Okay, this is the question for today. First question of the class. Express x comma y. This is an ordered pair. I hope you remember what an ordered pair is. Such that x square plus y square is equal to 25, where x comma y belongs to whole number. A set of ordered pairs. All right. So you have to represent this as a set of ordered pairs. I'll give you a few minutes for this. Done.
Done.
Like, what is the answer here?
So x is 3 and y is 4.
X is equal to 3 and y is equal to 4.
3, 4. Yes.
3, 4. All right. Any more elements in this set?
4,
4, 3. Absolutely right. Is there any more elements?
5, 1.
5, 1. So 5
No.
square
No.
plus
So this is all. Or maybe 0. 5 and 0.
Give me a minute. All right. Just give me. Sorry. Yes. You're saying Fahad 5,
5, 0.
5, 0. Right.
And 0, 5.
0, 5. So these are all the elements you need to write. Right. Suppose I told you x, y belong to z, where z is integers. So how many more elements would we have to add?
4 more.
4, 1. So 4 square plus 1 square is not 25, I guess.
No, I said 4 more. 4 more elements.
4 more. Which are the elements for?
-3, -4.
Absolutely right. And -5, right? All the combinations of that, right? In fact,
Yes.
not 4 more, but there is a set element this also, -3, 4 also, right?
Yes.
So you can count as many more you have to add. All right, Fahad?
Okay.
And Arnav, is this clear?
Yes.
All right. So let's move on. In the last class, I told you about relations also. Right? Relation is a subset described. How do we obtain this subset? We describe a relation between A and B, right? First element and second element. The second element is called image of A, right? And suppose A comma B is a ordered pair that is belongs to R. So we write A is related to B, or we write as A R B. All right. If A comma B does not do R, and we say A is not related to or A B. All right. What does this two line means? Suppose there is a R set and we have 1 comma 2, 2 comma 4, 3 comma 6, and so on. So 1 comma 2 is an element in R. So we will say 1 comma 2 belongs to R, or we can say 1 is related to 2, or we can say 1 R 2. Is this clear? Three types we can denote the related elements. All right. Enough art. Is this clear?
Yes, sir.
All right. Note it down. Then we'll solve few questions. Done?
1 second, sir.
All right. All right. If you have noted down this, then write down this question. Tell me when you are done. Have you noted down the question? Fahad, Arnav,
No, sir. One. Sir, I do not understand how to do this.
No, I'm not asking you to solve. I'm just asking you to note down the question. I'll explain how to solve. See, they are saying a relation R is defined from A to B, right? That means what is R? R is a subset, right? Subset of what? Subset of Cartesian product from A to B, right? This thing is clear. R is always a subset of a Cartesian product. Here the Cartesian product is from set A to set B. Is this thing clear?
Yes.
Right. So first we can write the Cartesian product. So Cartesian product will be 2, 3, 2, 6, 2, 7, and 2, 10. 3, 3, 3, 6, 3, 7, and 3, 10. Right? 4, 3, 4, 6, 4, 7, 4, 10, and 6, 3, 6, 6, 6, 7, and 6, 10. This is the Cartesian product. Nobody has any issues with this, right? All right. So now they are saying R is a relation in them. And remember, how do we describe the subset? The subset is got by defining a relation from the first element to this element, right? One condition is defined from first element to second element. Fahad, can you tell me what is the condition here between x and y?
X divides Y.
X divides y. So you have to choose the order pairs such that the first element will divide the second element. And divides mean divides completely. All right. If you see this type of questions, the division means complete division. All right. So if I take 2, 3, does 2 divide 3? That is
No.
true or not? So this will not belong to R. All right. So if we try to write this set R, what are the elements that will be here?
2, 6, 2, 10,
Right. Right.
3, 3, 3,
Right.
6.
All right.
6,
That's all.
6.
6, 6. Is that all?
Yes.
Right. So these are all the elements that are in R. All right. So this is the relation R. Is it clear now?
Okay.
Arnav, this is clear?
Yes, sir.
All right. So you don't have to write this A cross B all the times. This was just to explain you what you are doing, right? So you can just look at the elements and think about which element divides which element, right? So you can write the relation set easily by yourself without writing the Cartesian product set. All right. This was just to explain you what we do for more clarity. Do you want to note it down, everyone? Fahad, Arnav?
And I have no.
Yes, sir. Writing.
All right. Let me give you another question. Let A equals to 1, 2, 3 till 14. Define a relation R from A to A by R equals to x comma y such that 3x minus y equals to 0, where x comma y belongs to A. Right? All right. Please try this question by yourself. This 1, 2, 3 dot 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 till 14. All right. They are saying let A be a set from 1 to 14. Define a relation R from A to A by R equals to given by R equals to x comma y such that 3x minus y should be 0, where x and y belongs to A. Write this set R. All right. Can you try this by yourself, Arnav, Fahad?
Okay.
All right. Tell me when you are done. Have we solved this? Fahad, Arnav?
Yes, sir.
All right. What is the answer here?
So R equals to 1, 3, 2, 6, 3, 9, 4, 12.
All right. 5, 15.
Hmm. So this is all.
Sorry.
This is all.
This is all. All right. Arnav, clear how we got this answer?
Yes, sir.
All right. Let me explain, but for my satisfaction, we can write y equals to 3x. Just put the value of x and you will get y. Y and x cannot exceed 14 or less than 1. So these are the elements you will get. All right. Next question. You don't have to write a cross a here, right? We can just find the answer by writing this relation R. Let's find the question. Define a relation R on the set n of natural numbers by R equals to x comma y such that y equals to x plus 5 x where x is a natural number less than 4, x y belong to n. All right, try to solve this one. Solved it? And now Fahad. Solved it or not?
Done.
What is the answer here?
1,6, 2,7, 3,8.
Absolutely right. Because x is less than 4, so 1, 2, 3 are the values, and y is always 5 more than x. So 1 plus 5, 2 plus 5, and 3 plus 5. So this will be the answer. And now this is clear.
Yes, sir.
All right, next question. Let R be the relation on the set N of natural numbers defined by R equals to A comma B such that A plus 3B equals to 12. A belongs to N, B belongs to N. Find R. All right, try to solve this one. Tell me when you are done.
Done, sir.
All right, what is the answer here?
Sir, 0,4,
All right,
3,3,
all right,
6,2,
all right.
9,1.
9 comma 1. The same answer you are getting, Fahad?
Yes, sir. Same.
Same. All right. So can any one of you tell me what is wrong with this answer? Is there anything wrong with this answer?
Sir, A can't be 0.
A cannot be 0. Absolutely right. Right, enough. We are saying A and B belongs to natural number and 0 is not a natural number. So 0, 4 cannot
Okay.
be an natural number, right? So you can easily find out by solving this that A is equal to 12 minus 3B. Just put B equals to 1. So you will get 9. B equals to 2. So
Sir,
6.
B can also be 0, right? Because B is whole number.
No. Sorry. B, this is N actually. My handwriting is bad. This is N. All right.
Oh, okay.
Because in the set of N, right,
Okay, sir.
we are taking the products from N. All right. I hope this is clear. You can note it down if you want. Done, everyone?
Yes, sir.
What is domain of a relation? Right, this is very easy. the set of all the first elements of all the ordered pairs in the set R is the domain of R. Alright, very easy. If I write a set R, this is relation set R 1 comma A, 2 comma B, and 3 comma C. The domain is the first elements. So domain we can write domain of R is 1, 2, and 3. All right. All the first elements of the ordered pairs are called domain. Is it clear? Arnav, Fahad?
Yes.
Arnav, Fahad, this is clear, right? Very
Yes, sir.
easy, right? You just have to find out the ordered pairs that belong to R, write down the first elements. So those are domain. Note it down. Done.
Yes, sir.
All right. What is range? Range is just the opposite, the set of all second elements of all the ordered pairs in the set R is the range of R. All right. For the same example, 1 comma A, 2 comma B, and 3 comma C, if we have, and range will be A comma B comma C. All right. Here, the elements are called domain. Second elements are called range. Note it down. Done. Fahad, Arnav.
Yes, sir.
Now the third term we need to know is codomain. What is codomain? If R is a relation from set A to set B, then the complete set B is the codomain. All right. What does this mean? If I write, suppose A is 1, 2, 3, and B is 4, 5, 6, and R is 1, 2, and 2, 4. Suppose there is no 1, 2, 1, 5, and 2, 4. Can anyone tell me what is the domain here?
1 and 2.
1 and range
5 and 4.
5 and 4. And what will be codomain here?
Four, 5, 6.
Sorry,
4, 5, and 6.
4, 5, and 6. All right. So you get the difference between range and codomain. Codomain, you don't have to think. What is codomain? Set B is codomain. All right. And range, all the elements that are the second elements of the ordered pairs. All right. So there is a difference between range and codomain. So don't confuse with that. Codomain is clear, Arnav? Arnav, codomain is clear.
Yes, sir.
All right. Note it down. Done.
Yes, sir. Done.
All right. The representation of relation. A relation R from set A to set B can be represented in any of the following forms. First is same roster form. Can anyone take a guess what roster form would be in relation? Can anyone take a guess? No? In roster form, we represent a set, we represent a relation by that all the ordered pairs. In R. All right. So simply write all the ordered pairs, and that will be the representation of relation R. All right. For an example, if I give you a relation R, set A, which is -2, -1, 0, 1, and 2, to set B, and this is 0, 1, 4, 9, 16, defined by the rule A square is equal to B. So can anyone tell me what will be the relation R here? Fahad, Arnav, can anyone tell me what will be the relation R here?
Mm,
Your voice is not audible, Fahad.
yes, sir. The -2 and 4,
-2, 4.
-1 and 1,
All right.
0 and 0,
All right.
1 and 1, 2 and 4.
Right. 2 and 4. So you don't have to write anything else. If you write just this thing where you mentioned all the ordered pairs, this will be a representation of R, and this is called roster form. All right. Just as in set, if you write all the elements, then that is roster form. Clear, Arnav?
Yes, sir.
All right, clear, right? See, I know this is a bit boring thing, right? All the theory you have to learn, but see, if you don't learn the language, then you cannot speak, right? And if you cannot speak, then nothing can be interesting. So we have to go through the boring part first, then we will different type of questions, and that will be very interesting. All right, so please move on. Done. Arnav, Fahad, have you done writing this?
Yes,
1
sir.
minute.
Done?
Yes.
What is set builder form? Set builder forms a relation R from A to B defined as R equals to all the ordered pairs A comma B such that A belongs to A and B belongs to B, and A and B satisfy a condition or rule that associates A and B, right? All the definitions of relation that we are doing in the questions, that is called set builder form. For an example, if I give you a set A where we have 1, 2, 3, 4, 5, and set B we have 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, and so on, right? And the relation set is given as 1, 1, 1, 2, 1 by 2, 3, 1 by 3, 4, 1 by 4, and 5, 1 by 5. Suppose this is the relation set. So you can define this relation R in set builder form as all A comma B such that A and B belongs to, A belongs to A and B belongs to B, such that we can write B equals to 1 upon A, right? Whatever A is, B will be the reciprocal of that. So this way we can define the relation R. So this will be set builder form, in which you don't write the elements, but the rule, the condition that associates A and B. All right, this is clear? Arnav, Fahad, is it clear?
Yes, sir.
All right, note it down. Done?
Yes, sir.
Third one is arrow diagram. And I think Arnav you asked this in the last class, right? Is there any way to represent using Venn diagrams?
Yes, sir.
So this is what arrow diagram is. To represent a relation from set A to set B in arrow diagram, we need to draw arrows from the first components to the second component. Right? This will be clear with an example. suppose we have a set A 1 2 3 4 5 and set B 2 3 4 5 6 7, right, and a relation R 1 comma 3 1 comma 2 2 comma 3 3 comma 2 and 3 comma 4. Let's suppose this is the relation R. So what you have to do, you have to draw a circle, and this is set A. Draw this circle, this is set B. Write all the elements of A here, 1 2 3 4 5, and set B here, 2 3 4 5 6 7. The next step is to draw arrows from the first element to the second component. So 1 2 3, 1 is connected by 3, so one arrow will be connected from 1 2 3. All right, 1 and 2, so one arrow will be connected from 1 to 2. 2 and 3, so one arrow will move from 2 3. 3 and 2, so 3 will be connected with 2. And 3 and 4, so one arrow will move from 3 to 4, and rest will be as it is. Is this clear enough, Fahad?
Yes, sir.
Right, this is very easy, and this is relation R. Like, this is called arrow diagram, which we will use a lot. Right, Fahad, this is clear?
Yes, sir.
All right, and this, please understand this very clearly, this will be used in class 12th also. Very important. All right, so please note it down. Done.
So one second. You're done.
All right, so everything clear with today's class? Any doubts on this, Fahad and Nav?
No, sir.
No, sir.
Right, so please revise this. All right, in the next class we'll do few more questions, and we'll learn what is a function. All right, that is very important. If you are preparing for IIT also, functions, as you already know, is very, very important. All right. So please focus on that and keep revising. All right. And in the next week, you have a test also. Please prepare for that also. All right. Enough hard. Clear?
Yes, sir.
All right. Then see you in the next class. Please take care.